Hello everybody, welcome back to From Rhythm to Algorithm. We continue on with our derivation. Now we're at a very important historical time actually, to reference our great predecessor, our great giant, Mr. Albert Einstein. And so if you said, what was the biggest intuition, right? What we're doing is, again, we've proven the consistency of conceptualization. Aha moments, light bulb moments are the same for everybody. You just have to kind of like work for it, get there, build the intuition, so on and so forth. But the biggest aha moment, the biggest development moment of learning for Albert Einstein was certainly his equivalence principle, saying that acceleration is equivalent to gravity. And so basically, if you're in a box, you can look up the experiment or his quote unquote famous thought experiment, which it's kind of an oxymoron. Experiments are not thought. But I guess it could be. I don't know. Doesn't matter. Not the point. Point being is his big intuitive conceptualization was this realization of a connection between the word gravity and the word acceleration. If you were in a gravitational field in a box without, like, I forget the actual experiment, but like if you're falling down, or if you're accelerating, or if you're in a gravitational field, it's the same thing. But in reality, right, gravity, linguistically, conceptually, it is viscosity. In its most general whatever, what that word is trying to represent is the resistance to movement. And so we have, again, velocity and viscosity are inverses. And so acceleration, we've built out that concept more. That's a concept that's hung around from Newtonian mechanics, but hasn't really been, again, this dichotomy of acceleration still meaning just a change in velocity, but to the negative side, we've discussed and kind of bolstered that it's more, conceptually, when you say accelerate, you're thinking increasing speed. And so a change of velocity to the positive is really what people conceptually understand. But regardless, meaning acceleration, generating speed, generating movement, facilitating movement, and viscosity, resisting movement. And so we see that linguistically, but it's correct, right? We're doing this derivation game completely independently, but what we've done is re-derived the equivalence principle. Because gravity is viscosity, and then the acceleration, they're just, again, his big, that's definitely a historical moment of understanding a physical inverse, right? Two sides of the same coin. You take a physical object, you remove it from equilibrium, and it's going to try to move. And so we're not going to re-derive all of the things we have derived, again, because these things aren't one-to-one, meaning you can't solve the stress tensor, Einstein's equations, those big long equations, you don't solve those equations, right? In reality, again, there are no logical paradoxes. In completeness, problems are wrong. Meaning, if you have a problem, if you're sitting there saying, I don't know how to reconcile gravity with the other forces, I don't know how to reconcile, particle physics with general relativity, that is the clear demonstration at a historical level of logical inconsistency, which we've proven doesn't exist. And so the big understanding linguistically and conceptually, physically, that gravity is viscosity. In totality, in generality, the resistance to movement. Acceleration is the facilitation of movement, the increase of velocity. More conceptually, mathematically, it doesn't really matter if you have it as just a change of velocity. As it's taught, it's super nuanced just in the presentation of the work. But regardless, that is historically what happened, is Albert Einstein understanding the inverse of, again, because I can personally feel, again, because of those two words that he related, gravity and acceleration, it's very clear the intuitive step that he's making. But it's just more of suspension, right? That when you're in his box and you don't have a mirror, or you can't see if you're moving or whatever, because that's like his big insight. It's like you can't tell if you're moving if all of like the force is constant, or you can just go look up the experiment because it's not complete. And so, but that is a physical inverse of gravity being viscosity, and viscosity kind of being the opposite of acceleration, right? Resistance to movement versus facilitation of movement. And so we 100%, again, completely re-derived what Albert Einstein had called and didn't complete as the equivalence principle. But again, I don't think there's any one single step that is like any more or less poignant than any other ones. There's just a ton of steps. And without this genuine attenuation to language, I don't know how else you could do these proofs. Like, I literally don't know. But that is what the equivalence principle, like how it historically came about. Because what I'm doing right now is in order. It's not just proving all of these things. It's not just reducing all of the proofs. It's doing it in order. And so, yeah. Moving on with our derivation, what is sensorality? What is the relationship of logic and analysis, right? If I'm in math class, right, people say, oh, you don't get to proofing until you do real analysis. We're pretty doing some real analysis right here. When you use logic to analyze. And so analysis, I want to say, is more of like a procedure of applying logic with experimentation. Again, just posing a question, what relationship is between logic and analysis? Clearly, it's like when you think those two words, you're thinking kind of in the same, same book, same page, are they on the same sentence? But any of these questions are rhetorical, but they're also open questions. It's like, what is this relationship? This reduction process of sensorality, again, is one of infinitely many axioms. So I'm just providing you as much insight at every step of this process as possible. Sensorality is real analysis, like the entirety of conceptually what is represented in math class. When they say real analysis, I'm over there like, yep, we're really gonna analyze some things. And so, yeah. What is mass to potential, right? Energy, we started with, and again, we're showing you this evolution of conceptualization of physical law, right? Energy, the capacity to do work. Yeah, it makes sense, and it does. And last time, right, well, what is the capacity to do work? Work requires movement. So if work requires movement, then energy is the capacity to move. Energy is movement potential, is what I put on the screen. And people are like, potential energy. But no, it's like exactly wrong. Like it's exactly wrong. We've shown that it is such a poignant result. And it's just literally the order of words, but order matters. I mean, this whole chronology aspect, which is overwhelmingly apparent, things happen in a given order, is not accounted for in like physics, like at all. Right? All of these symmetry laws, all of this dichotomy, this, we have particles and we have waves, we have forces and we have particles. It's all of this dichotomy is after this universal evolution of inversion to opposition to stabilization, which is stabilization is also completeness. Right? That's where you get dichotomy from, is this fundamental stability of two. And so like just like the entirety of physical structure, or like theoretical physics. And I hate the word theory because physics isn't theoretical. But this whole edifice and like just the biggest absence is chronology. The simplest inversion that hasn't been identified, again, is we always talk about the maximum speed being the speed of light. Why not the minimum speed? Again, like not even articulated anywhere. Right? And so that's kind of like the big thing. And they're all big. I don't understand how I had the opportunity to do what I've done. Again, the actual iteration proofing process out of your league completely. Sitting down and saying, what the fuck is anyone doing in physics is just right. It's so profoundly apparent to me. How does not somebody say the inverse of a maximum speed is a minimum speed? Half of the things you do in math class is like finding bounds. And so it's like, no one's like, hey man, everything's moving. There's gotta be like a minimum speed you can move to be like the opposite of the maximum speed you can move. Again, in like a structured research way. Nobody, ever. Go, 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 yeah. It's like, bro, do less, do way less. What is mass to potential? So that's what I was getting to. Potential, energy is a potential for movement. Capacity is potential. What is potential? Potential. It's built on tension, once again. Potential is tendency. We're at this aspect of irreducibility of language. What is mass to potential? Again, what has the potential to move is mass. Right? If you have a light particle, that is so much AIDS already. It's been AIDS, it's AIDS again. I even have some syphilis now. But light is not a particle. Like the rippling is a speed limit. When you look at a wave, when you see the heat coming off of your grill, that's like, again, the information being transferred along this tension path of these discrete objects. When you crack a piece of glass and it fractures all jig-jaggedy, that's information being transferred along the tension path of discrete objects. So mass is the only thing that has the potential for movement. As structured physics theory presents it right now, light doesn't move. Light is not a particle. That's the biggest thing, is these bosons. You can't represent massless particles as a logical contradiction immediately. A particle is a unit of mass. It's a section of mass. Particles are discrete. And so again, it's not there's no, when you see the heat waves coming off your grill, there's no medium going through anything. It's just the information has to reflect off of discrete objects. Oh my goodness. But mass to potential, mass is the only thing that has the potential for movement. In general, potentiality. And that could happen. Potential could. You wouldn't, should, would, could. Potential could. But logically at irreducibility. I saw Kurt Jaimungo committing some nice fraud. Again, another one of these goofball, cornball, dorky dorksters out there talking about, he types the word none, N-U-N, and says, I saw this on YouTube, none is a you doing a cartwheel. Good job, Kurt. Are you aware of my work? Yeah, you are, Kurt. You just committed fraud. Again, like 1,000,000 times. Obviously, anybody sitting on stage is going to prison for the rest of their lives. That's not a joke. The fact that I can't literally say that to their face, go into Harvard jerk-off hall, stuff the whole auditorium full of people, defend my PhD thesis. There is nothing more in this world that I want than to defend my PhD thesis, quote unquote. Again, stuffing a bunch of arrogant dickheads into an auditorium. And presenting, again, I'm not sure what exactly I'd present. I would literally just start proving their thoughts to them, like actually. And so, but meaning, God, just I want to call, like, I clearly am calling people. I want like people to take responsibility for their actions. I want there to be punishment, law enforcement, cuffs, wee woo, throw them in jail. But none doing a cartwheel, that's true, Kurt, and that's because of geometric linguistics, an entire section of mathematics that the world does not know about. Wow, where could that insight have come from, Kurt? Fucking thief. What is averse to adverse? All right, add 1D. If you're averse, I say I'm averse to something. Like aversion repels. Adversity is challenging. Pulse, repulse. And now again, it's at this point where it's like I'm trying to like explain something, but then I just rederive the same theorems and words have meaning. At this point, again, we're on part 292. There's nothing for me to say. You have to learn, classmates, little student out there, little Sean Carroll Ed Wittens. You guys gotta have to learn. Put on your thinking caps, big guy. Maybe one less banquet. Maybe one less conference with Brian Greene. Fucking criminals. The big thing of this, again, was to explicitly talk about the equivalence principle. Again, more from a historical aspect, because acceleration to gravity, it's kind of like a one step away from identifying an inverse. Velocity being the inverse of viscosity. Gravity is literally one-to-one viscosity. Acceleration, it's not a bad word, but it's not a great word. But yeah, viscosity is the inverse of velocity, and acceleration is more towards the increasing. We already went through it. That's why I pointed out what I could. And again, they're not. Science is solved. Physics is done. Publish my paper. Fuck all you people. 2 is complete. That is, we can reduce the fundamental stability of 2 to just saying 2 is complete. Fundamental stability is completeness. Subsequently, irreducibility is unbreakable, right? If you have something that's complete, you can't break it. These fundamental things called mass, protons and neutrons, well, neutrons aren't real because that has charge distribution, but so do electrons, and protons don't functionally have charge distributions, but they're stabilized dynamics of 2. And it's just like the outer shell or the inner shell. In the same way, again, we have this proportionality where if you have electricity, it's traveling on the surface, and the relevant part of the proton or neutron that's interacting with other things, right? This bounding is internal. That's where you get the intra versus the inter linguistically. But in the same way you have surface charge is the one that's transmitting electricity. You have surface, the stability, you have pretty much a net neutral charge. The neutron, it has a charge distribution, but it's closer. The actual, again, proton and electron are fundamental stabilities, and they're inverses of one another. And so it's like the outer, the surface of the dynamic gives it the positive or the negative. But that, again, like I said, that's the proportionality scaling. I mean, that's directly true for atoms, right? Not just individual electrons or protons, but all physical dynamics scale. And so And there still is an absolute minimum. We just can't access that with measurement, and nobody can. Like, there's not, like, if you go find the super big triple quasar, probably still can't. You can definitely layer atoms. That's to the technology aspect. We'll get to that again. Still going to do that video. But once you have completeness, then you have irreducibility, right? Kind of the logical inverse of something that's complete is it's irreducible. Irreducibility is unbreakable. So that bridged something logically for me to point out rather explicitly. But we've been saying the irreducibility, but then I've also said kind of just, there's certain sections where it's like, yeah, he's definitely doing derivation, the other times he's talking, but you can't, and then I'll say you can't break language, right? Irreducibility is unbreakable. So this is the whole time, like I'm just forming this logical structure to show you that words have meaning, because you guys are arrogant. Which I still don't know if I can say that word, but I say it a lot, so it's like, ugh. Who cares? Who cares? I might edit it out, but only, again, the fact that I have to edit anything with my natural presentation of language is hilarious. Sensorality is unbreakability. A break is a hiatus. A break is a gap, right? We have this gap in mass. We can't break this fundamental dynamic. And so this encapsulation, this dynamic, again, encapsulates this gap. That's why you can have internal temperature. They're bonded. The dynamic is sharing the different electrons. That's why I'm me. I'm not like disintegrating or turning into a big light being or something. But if you say, hey, let's go on a break. It's break time at work, right? There's a gap in your timesheet. Breaking produces gap. A crack is a fracture. Fracture produces factor. If you can break something into two, if you can disintegrate it, look at me, right? Integrate, disintegrate. If you can disintegrate it into more than one pieces, it's a factor or fracture. It doesn't matter. I'm just building the linguistics, trying to find the stabilizing, find the right question. What is sensorality? Show the direct iteration of the letters. Definitely point out the equivalence principle was properly, and that was his big, Albert Einstein's 100. He used the wrong words. Again, I told you, we can feel your intuition. With, even if you get all of the words wrong, you can 100% feel your intuition. His intuition was the reciprocity, the inversion of the velocity and viscosity, and he articulated it as gravity is the same as acceleration. So that is what I have for you today. Thank you for watching. My rights continue to be violated. Pay me, fuck you. See you on the next one.